Hi students, good evening to you all. My name is Ritesh Mishra. Today we are going to start that chemical properties of halocranes. Okay, so two chemical properties we are going to discuss now. The one, how alkyl halide react with the organometallic, how alkyl halide react with the ambident nucleophile, and second, how the Grignard reagent react with the alkyl halides. So two chemical properties in detail we are going to discuss here. If you understand perfectly, please like and subscribe and share with the friends. Okay, so let's start. See students, here I write here the two ambident nucleophile. Ambident nucleophile means those nucleophile which have a two donor side. Okay, two donor side is called ambident nucleophile. So we have here one is AgCN, second is NaCN. Okay, so and one is KNO2 and here is AgNO2, right? So we have two here, but other also can be possible. First to understand, student, AgCN is what? AgCN is a covalent compound. What happened? AgCN is covalent compounds, and as you know, the covalent compound is not ionized, correct? So when it will not ionized, in that case, that will not dissociate or ionize cations and anions, correct? When it will not ionize cations and anions, then how it will act as a nucleophile? Then in that case, the lone pair of the nitrogens will act as a nucleophile, correct? Because it is not going to be dissociated or not going to be ionized. So since not going to be ionized, so it will not form any anions or cations. So in that case, students, Cn negative, here is a lone pair which will act as a nucleophiles, and the process will be through the SN2 process, correct? So when we take the alkyl halide, so the Cn minus Cn lone pair will attack on the carbon positions, so that the halogens will leave the positions and that form the R and C alkyl isocyanide. Alkyl isocyanide, correct? So alkyl isocyanide will form, right? Now we talk about NaCN. Student, NaCN is a what? Ionic. This is the what? Ionic compound. So it will ionized. It is going to be ionized. And how it will be ionized? Na plus Cn negative. You can check here where the negative charge is present. The negative charge is present at the carbon position. And as you are aware, the negative charge and lone pair both can be in nucleophiles or base. Okay. So the Cn, it means the carbon attack on the alkyl halides. So when we take the R, Cl, and Cn is here, the carbon position, so that will attack on the alkyl group and the halogens will leave the positions. So that will form RCN, alkyl cyanide. Alkyl cyanide, correct? So alkyl cyanide will form. And the student, remember that this is the process is SN2. So don't take the 3 degree or 2 degree like that, okay? And the process is going to be the alkyl cyanide is formed. Okay, now we talk about the KNO2. The same logic will apply on the KNO2 with the KNO2 and AgNO2. The same logic will apply. What logic? KNO2 will behave as a ionic compounds. So just you note on that. Okay. So now the same logic we are going to apply here. What logic? See, the KNO2 student is what? Ionic compound. So KNO2 is ionic. It will dissociate as a K plus and NO2 negative. You can check here where the negative charge is there. So negative charge is there on the oxygen atom. So attack so oxygen will attack on the alkyl halides. So when we take the alkyl halides, so O and double bond O, here is a lone pair exchange. Here is also lone pair is negative charge. So this negative charge is going to attack on the alkyl positions and halogen leave that. Okay, and so that the compound are O and double bond O. Alkyl nitrile. This is the alkyl nitrile is formed. Correct? On the other hand, when we take the AgNO2, what will happen? The same logic we will apply. When we take the when we take the AgNO2 is what? Covalent. So it means there is no ionization and no dissociation will happen. So the nitrogens which have a lone pair of electron attack on the alkyl halides. When we take the alkyl halide and NO2, here is the lone pair. Okay, that is going to attack on the alkyl positions, and at the same time hydrogen leave the positions. So that what happen? NO2 will form. Correct? That is a nitroalkane is going to be formed. Nitroalkane is going to be formed. So that is the logic of, but don't forget the process is going to be the SN2 process. Okay, so I hope you understood what is the use of ambident nucleophile, how ambident nucleophile will attack on the alkyl halides. Now second point is reaction with the Grignard reagents, how alkyl halide react with the Grignard reagents. Let's understand that logic. See here. See students, how alkyl halide is going to be react with the Grignard reagent. See, RMgX is Grignard reagent. Students, what the reagent is? This is the Grignard reagent. Okay. Now see here. This is called OMC, organometallic compound. Organometallic compound is the when the carbon attached with the metal is organometallic compound. So Grignard reagent is organometallic compounds. Student, the Grignard reagents is RMgX. Okay. So RMgX, this side is the covalent and here is the ionic. So despite being, since metal is there, and you know, when the metal connect with the alkyl group, alkyl develop a negative charge because the metal can donate electron to the alkyl group. Okay. So here the metal can donate electron to the alkyl group. So alkyl contains negative charge. Similarly, halogen is a more electronegative atoms. So that will take the electron from the magnesiums and it is also negative charge. So okay. But here we write that actually Mg is always combined with the halogens because ionic compound is there. So since R contains negative charge, students, so it can act as a base and nucleophile. So when you start the study of the hydrocarbons and then finish the amines, every chapter you are studying, every chapter you study that Grignard reagents, chemical properties or method of preparations, because Grignard reagents act as a base and nucleophile both. So in the alcohol chapter, it will act as a base. In the aldehydes or ketone, it will act as a nucleophile. Correct? In amine, it will act as a base. Wherever there is a free protons, free acidic hydrogens. Acidic hydrogen means when the hydrogen connect with the more electronegative elements. Okay? That is the acidic hydrogen. So whenever the acidic hydrogen is there, Grignard reagents can react easily. Therefore, Grignard reagents can react to water vigorously. When we take RMgX and water which is HOH, oxygen connect with the hydrogen, so say acidic hydrogen, here is the negative charge, it will attack and form the alkane plus MgOHX. Okay. So Grignard reagent is highly reactive students. Now your question is, which halogens is the faster? Which halogen will attack? Which halogen will be faster? Better Grignard reagents. Students, keep in mind that iodine is a better reagent than the bromine, than the chlorine, than the fluorine. So best Grignard reagents in the halide terms are MgI, then RMgBr, then RMgCl. This is the Grignard reagents, and the good Grignard, best Grignard reagent than this, and then the chlorine. Okay. The now question is how Grignard reagents will react with the alkyl halides. Student, Grignard reagents reaction with the alkyl halide is SN2 process because here is the base and nucleophile. Correct? And base and nucleophile is usually attack on the SN2 process. So what happened? RMgX, when we take this R is a R dash Cl. Remember, it is going to the SN2 process. So this alkyl group is going to attack on this R double gas, and the process is going to be the SN2. It means that this alkyl should be that invergence. So here is the inversion alkyl, and here is the retention alkyl. Okay. So what happens, students? In that case, that will form the R double dash plus MgXCl. Okay. If you want to prepare the good compounds, symmetrical alkanes or higher alkanes, if you want to prepare good alkanes, then you can take that either the halide, I'm talking about R dash, either halide or benzyl. This compound would be give you better alkyl halides or faster Grignard reaction with this R double dash C. Means if you have halide or benzyl, the reaction will be faster. Okay. Now next case is where the Grignard cannot be used there. See, students, if you have a compound like that, see, if you have a compound like that, the bridgehead atoms like here is that suppose chlorine and bromine, and you have taken the CH3 and GX. So in that case, your reaction will not be proceed because the chlorine, it means the methyl group cannot attack on these positions because here there is a bridgehead atom. This is called bridgehead. So bridgehead atoms will never form a transition state or rather form the cations. So therefore that process does not be happen like that. Okay. Now the next point is, instead of the chlorine, if we take instead of the chlorine, suppose we take here, see here, instead of chlorine, if we take here, see here is the MgCl, okay, and here I have taken the or MgX I have taken, and here is CH3 MgCl. Okay, sorry. Here is the CH3 and Cl. Then of course the reaction is possible. That in that case it will act as a nucleophile, and that will attack on these positions. So what happened? Here is the here is the methyl group can be possible. So keep in mind the bridgehead atoms cannot contain the transition state or the any cations, carbon cations. Okay, but student bridgehead atoms contain the free radicals for stability. Okay, leave it that, but simply keep in mind here. Now the one more thing you can see that in the convergence, Grignard agent is also used to prepare the higher alkynes from the lower alkynes. Okay, see how Grignard agents, I write here how Grignard agents can be used to prepare higher alkynes. See students, here is first I write the preparation of higher alkynes. Preparation of higher alkyne from Grignard reagents. Okay, so how can we prepare it? See, HC triple bond CH. I have taken the acetylene. So student, acetylene is the acidic hydrogens, correct now? So when we take that Grignard reagent CH3 and GX is negative, that will attack on the base, and CH3H means methane will release, so that what happened? HC triple bond C and GX. Now this is the Grignard reagents. Suppose you have taken the RCl. R can be methyl, ethyl, propyl, anything. So now this completely which act as a base, that will attack on the alkyl group, in the alkyl group, and what happened? HC triple bond C R will form. Correct or not? So here the carbon chain, methyl, ethyl, propyl, whatever you will take, that compound will form, longer chain will form. So you can have a conversion. You can see the conversion. How can you prepare ethyl alcohol into butane ion? Or like this type of conversion, so many conversions in the NCERT. So that will help in the preparation of convergence. Okay. So two chemical properties we have finished today. You understood it? Okay. Thank you. Subscribe. If you are new, please subscribe the channel. Thank you so much. Have a nice day.